Good afternoon, ladies and gentlemen. My name is Pham, and today I will be the presenter of our team to introduce you the topic verifying UML-RT model of a conveyor belt system in the nuXmv model checker. And I will use our poster and follow each part one by one so that you can easy to follow what I'm talking about. So first, for the objective of this project, as you know that the conveyor belt system, when first appear, it makes a huge role in the industry when it can reduce a lot of workforce, when it can easily transfer tons of goods in a short time. So model and understand it with the real work environment requirement can help us to understand how it operates and how to improve its efficiency and throughput. So in this project, we will introduce a simple model of conveyor belts. As you can see in this case, just one main line and two induction line here, and 5 components that we will put it into the FSEN2021-RT and nuXmv. So after have the design, we put it into the FSEN-RT model and then translate to the nuXmv symbolic model checker for the property verification. Then we will introduce some value into it to verify the correctness of our translation, and then have a comparison with the log trace to know the difference between the FSEN-RT and nuXmv after we translate it. So into the FSEN-RT model part, as you can see here, our system had 5 main parts. A pair of sensor and controller will relate it to one induction line, and the microcontroller here will relate it to the main line. The top capsule here is like a synchronization part that it will make these 5 components work as a host. So at the beginning, the sensor here will generate the signal that the packet comes into the waiting slot. Then it will which packet comes first will be processed first, and then it will make the later come to wait and then request again. But if both come at the same time, it will work in alternative mode, 1, 2, and then 2, 1. Yeah. Then when it decides which one will drop the packet, it will set to the controller to do it, and the controller will confirm to the sensor again. Yeah, it's very simple one. Then after we have this RT model, we will translate it into the nuXmv based on the rule in Miss Sahu paper, and you can see the paper name in the reference part. So here we will take the main controller as the example for our work. So as you remember here, we have 6 states. Then we will translate 1 on 1, and we will have 6 states here too. 1, 2, 3, 4, 5, 6. And after we translate one by one here, we also have to pseudo state here introduced into the model to separate the trigger signal and the outgoing message. And also, after we include the 2 additional states, we will have to add appropriate transition in order to not miss any incoming signal while the model is in this state. Yeah, that's all for the task part. And then into the property verification part, we will take the small part here to work as an example. So after we have the whole nuXmv model, we will include into it some flaw to understand the correctness of it. We want to make sure that our translation doesn't have any problem. So as you can see here, the right case here in wait request 1 2 here, when two buckets come at the same time, it will work in alternatively mode, that it will drop one bucket and make the other bucket to wait and request again. However, in the floor here, we will let it to drop immediately both the bucket. As you can see here, the controller will work at the same time in state 1.8. And normally, if our translation fails, the nuXmv will notify that our model still works well. However, in this case, it shows us the error. So finally, we understand that our model works well because the nuXmv can detect the problem that we input into it. Then after that, we have a comparison between the Conveyor-RT log tray and the nuXmv log tray. As you can see here, the packet will come at the line 2 at 1 and line 1 at 3. It's the same, and also when it drops, line 2 is dropped first and line 1 is dropped second. Yeah, it's the same also in the nuXmv. However, as you can see here in Conveyor-RT, the drop successfully at both 11. When in this case, it has a huge difference of more than 10 steps from 110 to 123. So this difference can be traced from different time steps into model. So in Conveyor-RT model, the time in the log tray is in seconds. However, the actual time step of the simulation is as small as the processing speed of a computer. So when a request comes, it's processed almost immediately. When in an nuXmv model, it's processed in discrete simulation steps, so the numerous nuXmv steps can be done in Conveyor-RT just in terms of nanoseconds and considered instantly. So in the end, it's not so different in the real time, but when you see the log tray, it's a huge difference here. Yeah. So for the final part, the model system I think could be enhanced more with induction line and more sophisticated merging algorithm to increase the efficiency and also the throughput of the system. The time lapse in the UML-RT model in real time is in terms of seconds, so it's simply just a step counter, and this could be improvised by exploring the use of the clock and the time automata in nuXmv. Yeah, this is the end of our presentation, and if you want to read about the translation rule, you can read the Miss Sahu paper here. Yeah, thank you for listening.